Yeah, students, please reply. Could you hear me? My voice is audible.
Yes,
Yeah, yeah, fine. Shall we do the problems?
yes.
Yes. So, 1 minute. Yeah, you could see the screen, right? Screen is visible, right?
Yes, sir.
Yeah. Go for the page number 134. Look at the problem number 1. Doing one simple question only. Try to solve it. Very simple question.
Sir, page number.
134. Problem number 1. Yeah, this problem has to do. It is simple only. Yeah, anyone did know? So here, resistance is given. Resistance is 20 ohm. It is stretched so that length becomes n times. If length becomes n times, then new resistance R dash is equal to n square R times. Then R dash is equal to n square is 20 square. Sorry, n square is 3 square because it becomes 3 times. So 3 square into R value is 20. So 3 square is 9. So 9 into 20, that is equal to 180 ohm. So new resistance R dash is equal to 180 ohm. Okay. Third problem is also same formula. Leave it. Then look at the question number 5. Problem number 5. Read the question properly, then verify the concept. You will understand which concept, based on which concept you have the problem. This week, Saturday also will take the class. Huh? Is it done? Problem number 5. Look at the problem number 5. Easy only.
Sir, option A.
Option A, very good. Still any other answers? Yeah, a uniform wire of cross section A and length L and resistance R is bent into a complete circle. Okay. The distance between any two diametrically opposite ends is. So the resistance between any two diametrically opposite ends is. Now total resistance is R1. Upper part resistance is taken as R1, lower part resistance is taken as R2. Then upper part resistance R1 can be taken as R into theta by 2 pi. So upper part looks like a semicircle. For a semicircle, theta value is pi radians. Then R into pi by 2 pi. Now cancel pi and pi. Then R dash is equal to R by 2. Sorry, R1 is equal to R by 2. In the same way, if you calculate R2 is also R by 2 because lower part also looks like a semicircle. I hope you remember the concept which we discussed. Yeah, for example, if it is bent into a circle and a battery is connected, I given this formula. Now R1 and R2 are in series or in parallel means parallel. For example, if I take this total current as I, the upper current is I1, the lower current is I2, then R1 R2 are in parallel. Then 1 by R parallel is equal to 1 by R1 plus 1 by R2. That is 1 by R parallel is equal to 2 by R plus 2 by R. Sorry, yeah, 2 by R plus 2 by R. You tell me more than what is this value?
Sir, R by 4.
Yeah, R by 4. So that is 2 by R if you take it as common, 4 by R. Then R parallel is equal to R by 4. This is the answer. So option A is correct. Then same like that, no difference. No, look at the problem number 6. Same like that. No difference is there. Please do it. Yeah, anyone did a simple problem only. Don't take time now. Yeah, don't take time. Easy problem only. Anyone did ma? Easy problem. Anyone did, please tell me. Hello? Anyone is there? Fine. I'll explain. Yeah, a wire of 12 ohm resistance per meter is bent into a form of circle of radius 10 centimeter. The distance between the two diametrical opposites, same formula. That is R dash is equal to R into theta by 2 pi. So theta is equal to pi radians. So R into pi by 2 pi. Then cancel pi and pi. That is equal to R by 2. So diametrically opposite ends, right? So you can take like this. R dash or R effective is equal to R by 4. Just now we calculated. R value is 12 ohm. So 12 by 4, that is equal to 3 ohms. Actually, they given a lot of things to confuse you. That's it. Okay. Nothing apart from that. They just given something to confuse you. That's it. Okay. So if you're done with that, we'll go for the next problem. Actually, it is very simple question. Nothing is there in this. Then look at the question number 9, problem number 9. Look at the problem number 9. Look at the problem number 9. Two metallic wires identically dimensional connected series. Sigma 1, sigma 2 are the conductivities of the metal. Actually, I given the same concept in terms of resistivity, but now they are asking about the conductivity. Please do it now. So you people has to do, you have to do, you must do this problem. Yeah, what is the answer, man?
Sir, 2 sigma 1 sigma 2 divided by sigma 1 plus sigma 2.
Yeah, option. Which option?
Option D, sir.
Option D, no? Yeah. Now tell me what is the effective resistance for the two resistors? connected in effective resistors for two resistors connected in series?
R effective equals to R1 plus R2.
No. Effective resistivity given. Effective resistivity. Yeah, in the previous concept only we discussed effective resistivity. See, somewhere else here we discussed this one. So two rods are connected in series. Then effective resistivity, this is the formula. Rho 1 L1 plus rho 2 L2 by L1 plus L2. Correct. So rho 1 L1 plus rho 2 L2 by L1 plus L2. So effective resistivity is rho 1 L2 plus rho 2 L1 by L1 plus L2. Now what they're asking the question, two metals wires having identical dimensions. Identical dimensions means L1 equal to L2 is equal to L1. Area of cross section A1 is equal to A2 is equal to A. Then effective resistivity can be taken as rho 1 L plus rho 2 L divided by L plus L, that is equal to 2L. So if you take L as common, rho 1 plus rho 2 into L divided by 2L, cancel 2 and 2, sorry, L and L, then rho effective is equal to rho 1 plus rho 2 by 2. But they're asking in terms of conductivity, we know that rho is equal to 1 by sigma. Then you can write 1 by sigma effective is equal to 1 by sigma 1 plus 1 by sigma 2 divided by 2, which can be taken as sigma 1 sigma 2 is the LCM. Numerator is sigma 1 plus sigma 2 divided by 2. Then rho effective can be taken as 2 sigma 1 sigma 2 divided by sigma 1 plus sigma 2. So option 4 is correct. Okay. So option 4 is correct. This is problem number 9. So far we discussed all the models, what we discussed and what we learned based on this concept. Okay, so far we discussed every concept. I mean, most of the problems based on this concepts, what we discussed till now. Okay, if you're done with this, we'll go for the next question, next concept.
Yes, sir.
Yeah. So the next concept, no, write down power. Power and energy. Now, for example, I'll take it as a battery. Battery is nothing but, or a cell is nothing but, it consists of some electrolytic solution like this. It consists of some electrolytic solution. Inside this electrolytic solution, we have two plates. Namely, one is electrode, another one is cathode and anode. And these two are connected to the external resistor of resistance R. And let us take current is flowing like this. And let us take current is flowing like this. Then we have one formula. No? The potential difference between the plates is given by V is equal to delta W by delta Q. Understood this point? Then delta W can be taken as V into delta Q. Then that delta W can be taken as V into delta Q. The delta Q can be taken as I into delta T. Okay. So then substitute these values here. Then delta W is equal to V value is taken as V only where V is potential. And delta Q can be taken as I into delta T. Understood this point? No? So this is the value of delta W. With this delta W can also be taken as kinetic energy because the charge is flowing along the cell like this. Or repeat, the charge is flowing along the cell like this. Okay. So for example, I'll take it as kinetic energy, which can be taken as V into I into delta T. Okay. Now I will take the total kinetic energy, or else I'll take change in kinetic energy, because change in kinetic energy is nothing but work done. Now please remember, we know that the total energy is equal to kinetic energy plus potential energy. Then change in total energy is equal to change in kinetic energy plus change in potential energy. Okay. Now please remember one point. No? Total energy of any body is constant. So total energy is always constant. Then change in the total energy delta T is equal to how much is zero. So change in the total energy is always taken as zero. Then delta kinetic energy is equal to minus the delta potential energy. Then delta potential energy is equal to minus the delta kinetic energy. So the delta kinetic energy just now we calculated, that is minus V into I into delta T. So this is delta. Okay. Generally, this is taken as the energy stored or else energy lost across the resistor. So this can also be written like this. This can also be written like this. For example, I'll take it as equation number one. So from equation number one, we can write like this one. Delta W by delta T is equal to V into I. Delta W by delta T can be taken as power. Now we know that power P is equal to delta W by delta T. Then that power can be taken as V into I. Then according to the Ohm's law, V can be taken as IR, substituted value here, then power P is equal to I square. This is the formula for power. Okay, or you can write like this also, P is equal to, I can be taken as V by R, because V is equal to IR, right? Then from this you can write I is equal to V by R. Then this can be taken as V square by R square into R, cancel R and R. Then finally, power formula is V square by R. Now, please remember, in this, need not to consider all the concepts, just only the formulas, because for PU examination point of view, derivations or nothing is asking. Just try to understand what is power, what is the formula for power. Okay, so P equal to V into I, P is equal to I square R, and P is equal to V square by R. These are the important formulas you should remember. So if you write directly formulas also, not a big issue. Just write on the formulas. Enough. Just write on the formulas directly, man. Then I'll go for the next concept. Shall I move?
Yes, sir.
Yeah. So don't think much about this concept. Just like formulas, you remember. No, this concept is very important. This concept is very important. Bulb. Now, please remember, if I take any bulb, so I will explain how to solve the problems based on bulb by using some examples. If I take it as a bulb, this is a representation of symbol of a bulb. In this bulb, we have two things are common. These two are called as rated power and rated potential. For example, if you purchase any bulb from the market, then in that bulbs we have maybe 40 watt, we have maybe 100 watt, we have maybe 60 watt or 1000 watt. Like that bulbs will be there. This 40 watt, 100 watt, 60 watt, 1000 watt, all these are the power. That power is also called as rated power. Okay, so please remember here PR is called as rated power. Now PR is called as what? No, rated power. Please remember. Or this is also called as wattage. And on the bulb, no, they will give like this. For example, rated potential is equal to 220 volts or 210 volts or 200 volts or else 330 volts. Like that, they will give the potential. This is called as a rated voltage. Now, after the class, you just open any of your bulbs in your room and you just see these two will be printed on the bulb. Okay, please remember these two will be printed on bulb. Okay, rated potential and rated voltage are printed on the bulb. Okay, so please remember, if you take any bulb, no, always on the bulb, two things will be printed. One is rated power, or that is also called as what? Wattage, or another one is rated voltage. These two must be printed on the bulb. Then from this, I will tell you few things. Understand very clearly. Understand very clearly, because most of the students are confusing here. Most of the students are confusing here. What is the rated power and what is the power loss? Okay, so please try to understand carefully. I will tell you. So first thing, to calculate the resistance of the bulb, not to calculate resistance of bulb. So I'll take like this. Not to calculate resistance of the bulb, I'll take like this. We know that power rated is equal to voltage rated square divided by R. Shall I take like this in this formula? Just now we calculated power rate. Just now we learn about the power rate. See, this is the formula given. Power P is equal to V square by R. So based on that formula, I'm going to calculate the resistance of the bulb. I'll take resistance of the bulb as RB. So resistance of the bulb RB is equal to V rated square by power rated. Please remember this formula. Okay. Now please remember. For example, I will purchase one bulb from the market whose wattage is 500 watt. Okay. Now, what is the meaning of this means? No, what is the meaning of this means? Maximum power it consumes. Okay, what is the rated power? 500 watt means maximum power it consumes is 500 watt. Similarly, what is the meaning of 100 watt bulb?
Maximum power it consumes is 100 watt.
Yeah, 100 watt bulb meaning is what now? Maximum power it consumes is 100 watt. Okay. So, for example, if a bulb consumes maximum power, or this is also called as wattage. Now, please remember, if a bulb consumes maximum power or wattage, then current through bulb is maximum. Okay, then current through bulb is maximum. But this concept is completely out of the PU textbook, but very important for the competitive. So, if a bulb consumes maximum power or wattage, then current through the bulb is maximum. Now, for example, if I take it as a bulb, I'll take it as PR, I'll take it as VR. Now, tell me what is PR and VR? PR is rated voltage, sorry, rated power, that is also called as wattage. VR is called as rated voltage. Then I is the current passing through the bulb, that is nothing but I maximum current. So please remember, then we can take like this, power rated is equal to voltage rated into current maximum. Because here we have the formula for power, P can be taken as V into I. Then maximum current can be taken as power rated by voltage rated. Okay, so if you can remember these two formulas, you will get most of the problems from these 2 points only. Okay, so we calculated the current and we calculated the resistance of the bulb. Please remember this. If you're done with this, I'll give you an example problem. Based on that, you can understand clearly how to calculate the problems on bulb.
Then I will tell you one more point. This is most important in the entire concept. That is brightness of the bulb. The brightness of the bulb depends on the power loss across the bulb. Please remember this one. So brightness of the bulb depends on what? No? Power loss across the bulb. If you understand up to here, then I will give you an example problem. Then you can understand how to do this one. Shall I move?
Yes.
Yes, sir.
All are in active mode only right now or sleepy?
No, sir, active.
So, shall I move?
Yes, sir.
Generally, at which time you people will woke up now? Just simply asking,
6.
6 o'clock, because of only class. Once all of it then you can understand this concept better. Okay, for example, I will take it as a bulb. I'll take rated power of the bulb is 500 watt. I'll take rated power voltage is 100 volt. Now I connected this to a battery. I connected this to a battery of, for example, 50 volt. Okay. Now brightness of the bulb we have to calculate. Now question is brightness of the bulb is. Okay, brightness of the bulb. Just now I told you one point. I hope you remember. The brightness of bulb is nothing but what now?
Power loss.
Yeah, very good. Power loss across the bulb. Clear. The brightness across the bulb is nothing but power loss across the bulb. So to do this problem, please you have to identify one point. This is a rated potential. VR is rated potential. Please remember. VR is what? Rated potential. And this is their rate. This V is taken as okay applied voltage of a battery. Here only students are confusing. This potential they are taking one by one, and most students are confusing at this point. But you don't confuse now. At least once you practice, you can understand it better. This potential is applied potential. This potential is rated potential. Okay, so from this we are going to calculate first resistance of the bulb. Now I'll calculate resistance of the bulb. So if you calculate resistance of the bulb, we have the formula power rated by voltage rated square. Correct? Voltage rated square by power rated. Now voltage rated square by power rated. So what is voltage rated square? 100 into 100, because 100 volt divided by this is 500. Okay, please remember students. So in this point only mostly students are confusing. They are taking this voltage as this battery voltage. Battery voltage is different, rated voltage is different. So here to calculate the resistance of the bulb, we have to take the rated power, we have to take the rated voltage, but not the applied voltage. No, but not the applied voltage. Please remember this. Okay, then cancel 0, 0, 0, 0. Then 5 ones are 5 20s are. So 20 ohm is the resistance of the bulb. Okay, so please remember, students, what is the resistance of the bulb? Means resistance of the bulb is 20 ohm. So instead of bulb, you can keep a 20 ohm resistor. I hope you understood this. And this is the battery of 50 volts. Now I'm going to calculate the current through the circuit. I'm going to calculate the current through the circuit. So current I is equal to V by R. So V is 50, R is 20. Cancel. Current I is equal to 5 by 2. Okay. Then we have to calculate the power loss across the resistor. Okay. So current I passing through the circuit is 5 by 2 amperes. Now we have to calculate the power loss. Now power loss is different. Rated power is different. Power loss is different. Rated power is different. So how to calculate the power loss means series connection current is same. Yeah, could you see the board? My voice is audible.
Yes.
Now listen. For example, in order to calculate the brightness, we have to calculate the power loss. The power loss is given by the formula. The power loss is given by the formula I square R. So please remember, if the current is in series or if the resistors are in series, you have to use this formula. If the resistors are in parallel, then you have to use this formula. Power loss is equal to V square by R. Now in this V square is the potential of the battery. In power loss, V square is potential of battery. If you take PR, that is rated power, then PR can be taken as rated power, then we have to call rated potential square by resistance of the bulb. This is different and this is different. So don't confuse with the rated power as well as power of the battery. Fine. Now then power loss can be calculated like this one. So power loss is equal to I square R. I square is 25 by 4 into R value is 20 ohm. Cancel 4 ones are 4 fives are. So 25 fives are 125 watt. Now 25 fives are how much more? 125 watt. Now please remember, students, what is the wattage of the bulb? What is the wattage of the bulb? What is the wattage of the bulb?
500 watt.
500 watt. But what is the power loss? What is the wattage used? 125 watt only. No, what is the power consumed? 125 watt. So here power consumed is. Now here power consumed is. Okay, 125 watt. That is nothing but brightness. So 125 watt brightness the bulb will glow. Okay. Now the concept here is, if you increase the input potential of the battery, this 50 watts, let us take for example, you gives 100 watt. then its brightness will increases much more. Okay, means you may get here as some 450 watt or as 500 watt like that. Okay, so please remember this point. I hope you understood how to solve the problems based on this power loss across the battery. Sorry, across the bulb.
Yes, sir.
Yeah. If you're done with this, I'll give you a small concept how to calculate the power loss across each battery or in series or in parallel. If bulbs connected in series, bulbs connected in parallel. No, all are JE students only, right? All are preparing for JE only, right? Anyone is for NEET.
Yes, sir.
Yeah, NEET students, no. On this concept, I'll give you a shortcut. You can remember the shortcuts. Next concept. But for JE students, you have to understand the concept and you have to prepare that. Okay. So write down. Next one. Bulbs connected in series. Yeah, tell me, Shubha.
No, sir, I am writing neat. So I have raised my hand.
Oh, okay, okay, fine. Bulbs connected in series. I'll take two bulbs like this. I'll take the second bulb like this. Okay. First bulb power I will take it as PR1. Second bulb power I will take it as PR2. Voltage VR1. Voltage VR2. Now please remember, I will take this as for example, PR1, PR2 is bit difficult. Powers as P1, P2. Voltage as V1, V2. Then please remember, the resistance of the bulb 1 is can be taken as R1 is equal to P1 square by V1. Sorry, V1 square by P1. This is the formula to calculate the power. V1 square by P1. Now similarly, resistance, okay, of the bulb 2, that is R2 is equal to the resistance of the bulb P2 is equal to, or R2 is equal to V2 square by P2. Now for suppose if both the bulbs are having same potential, now if both the bulbs are having same rated potential, let us suppose rated potential of first bulb is equal to rated potential of the second bulb. In that situation, the effective resistance can be taken as, in that situation, the effective resistance can be taken as R1 plus R2. For example, if I take a V1 equal to V2, now for example, if I take V1 is equal to V2, then R1 can be taken as 1 by P1, R2 can be taken as 1 by P2, then 1 by power effective is equal to 1 by P1 plus 1 by P2. Please remember this in terms of series combination. Here in case of series combination, what is the power effectiveness? Effective power is equal to 1 by R1 plus 1 by R2. Now this is connected to an external battery of potential V volts. Are you clear? Now, if you want to calculate the power loss, so then power loss can be taken as I square into R effective. Are you clear? No, power loss can be taken as I square into R effective. Okay, so this is the total power loss. No, this is the total power loss. Please remember, no, total power loss. Then if you take
power loss across first bulb. Power loss across bulb that can be taken as power loss is equal to I square into R effective. That R effective can be taken as, please remember, R effective, sorry, across the bulb can be taken as power loss into resistance of the bulb. Then power loss can be taken as I square into R resistance of the bulb can be taken as, from this we calculated the resistance of the bulb, that is taken as rated potential square by power rated. Now from this concept we can take power loss is inversely proportional to the rated power. Clear? Now please remember, if power loss is more, if power loss is more, then if rated power is more, then power loss will be less. In the previous concept, I told you one concept, no? If power loss is less, then brightness of the bulb is also
less.
less. Okay. So JE students try to understand step by step what we did. Okay, so we calculated total power loss across the battery, we calculated total power across the bulb. Okay, now based on this, I finally will give you one shortcut. Okay, NEET students, please remember the shortcut, and JE students remember the procedure. Okay, what I did, this is the procedure. Okay, I didn't give any problem, I just given the procedure how to solve. Now please remember, for example, in series combination of bulbs, now please remember, in series combination of bulbs, okay, the bulb with, the bulb with more wattage, now please remember, the bulb with more wattage will glow, will glow less brighter. The reason is power loss is inversely proportional to the rated power. Now, power loss is inversely proportional to what? Rated power. If power loss is inversely proportional to the rated power, then we can say like this: power loss, okay, depends on what? Brightness. So brightness depends on what? Power loss. Okay, 1 minute. Then we can say like this: brightness is proportional to what? Power loss. So the bulb with greater power or wattage will have less power loss. If power loss is less, then brightness will also be less. For example, I'll take two bulbs like this one. This is the first bulb. I'll take it as second bulb. So first bulb power is 50 watt. Second bulb is power is 100 watt. Now tell me, with these two bulbs are connected in series. Now tell me, which bulb will glow more brighter? Hello. Are you hear me?
50 watt. 50 watt.
Yeah, 50 watt. Yeah, 50 watt. Why? Because power loss is inversely proportional to the wattage. Which bulb is having less wattage, that will have more power loss. If power loss is more, then brightness will also be more. Then in series combination, the bulb with less wattage will glow more brighter. Okay. In the same way, in parallel combination, the conditions will be reversed. So in parallel combination, the bulb with the greatest wattage, the bulb with the greatest wattage. For example, I'll take two bulbs. No, this is 200 watt. This is 150 watt. Now tell me which bulb will glow more brighter.
200 watt. 200 watt.
That's it. That's it. This is the answer. This is the concept. Okay. And in series combination, we got of power effective is equal to 1 by P1 effective is equal to 1 by P1 plus 1 by P2. Then in parallel combination, what is the power effective?
P1 plus P2.
That's it. Okay. So here only I will mention one more point. For example, bulbs connected in parallel. Bulbs connected in parallel. So this is the first bulb. power P1. Now this is the second bulb, it's power P2. Okay, this is the second bulb, power P2. Now these two are connecting parallel. Then what is the effective power means P1 plus P2. Now here you can write like this: now power loss is equal to V square. Now power loss can be taken as what? V square into R effective can be taken as, or R effective you can write like this R. But we know that V is equal to IR. Then you can cancel like this. Sorry, one minute. In parallel combination, we have to take a power loss is equal to V square by R, where R is resistance of the bulb. No, where R is resistance of the bulb. Then resistance of the bulb, we calculated the formula. What is the resistance of the bulb formula? Rated potential square by power rated. Then that implies power loss is equal to rated potential of battery divided by rated potential square into power rated. This is the formula for power loss. Okay, shall I explain it again or else? See, in parallel combination, voltage is same. In parallel combination, voltage is same. In parallel combination, voltage is same means then you can write the power loss formula as V square by R, resistance of the bulb. Okay, so in parallel combination of bulbs, because in series combination means current is same, then power loss can be taken as I square into R. So this is in series combination. In series combination, current is same. In parallel combination, potential is same. Then power loss can be taken as V square divided by resistance of the bulb. We calculated already. Voltage rated square by power rated. We already calculated the resistance of the bulb. Then substitute that formula here. Then rated potential square by power rated. Then power loss equal to potential of the battery divided by rated potential into power rated. Then in parallel combination, power loss is proportional to rated power. So therefore, please remember in parallel connection of bulbs, in parallel connection of bulbs, the bulb with greatest wattage, the bulb with the greatest wattage will glow more brighter. Please remember these points, which is very important for competitive. So previously we calculated the power loss. Here also we calculated the power loss. In series combination, power loss formula is I square into VR square by PR. Whereas in parallel combination, power loss is V square by VR square into PR. Okay, where V is potential of battery, VR is rated potential. Okay, will you copy these two? Yes, series combination, you wrote a series combination. Write on parallel combination. And then you leave the class. Tomorrow we'll discuss the problems on bulbs.
Yeah, if you're done with this, you may leave the class. So tomorrow we'll discuss the problems on bulbs. Okay.
Thank you, sir.
Yeah, fine.
Thank you, sir. Thank you, sir.
Okay.